serum related problems. Okay.
అవును. Hello students. Hello.
Hello, ma'am.
Okay, ma. So in the previous class, we discussed about the potable water and its treatment methods, ma. So now we are going to discuss about reverse osmosis. Students, tell me what is osmosis? What is mean by osmosis? Students, you studied already about osmosis. What is osmosis? Hello. Hello, students.
Yes, ma'am.
What is osmosis, ma?
Process by which flow of solvent takes place.
Process by which flow the solvent takes
Low
place.
concentration to high concentration.
From lower concentration to high concentration when two solutions of different concentration, when two solutions of different concentration, that is low concentrated solution and high concentrated solution. We are taking different concentrated solutions, so that are separated by a semi-permeable membrane. Okay, so we are separating two concentrations. One is lower concentration we are taking one side, the other side we are taking high concentrated solution. The two concentrated solutions are separated by a semi-permeable membrane. Now, the flow of solvent, okay, the flow of solvent, for example, we are taking low concentrated solution. For example, we are arranging, that is, we are taking 5 grams of NaCl in 100 ml of water. 5 grams of NaCl in 100 ml of water, and high concentrated solution, we are taking 10 grams of NaCl in 100 ml of water. 10 grams of NaCl in 100 ml of water. Okay. So now the flow of solvent that takes place from lower concentration to higher concentrated solution. Okay. So what is solvent here? The solvent is sodium. The solvent is water and solute is sodium chloride. We prepared a sodium chloride solution. So low concentrated solution we are taking 5 grams of NaCl in 100 ml of water. And a high concentrated solution we are taking 10 grams of NaCl in 100 ml of water. So here one is concentrated solution, low concentrated solution, one is a high concentrated solution. Now the flow of solvent, what is solvent here? In sodium chloride solution, okay, solution contains both solute and solvent. Solute and solvent. Solute is NaCl and solvent is water. Okay, so the flow of solvent takes place from lower concentrated solution to higher concentrated solution. Okay, that process is known as osmosis. Okay, so the flow continues till the concentrations are equal on both the sides. Okay, so how this flow of solvent occurs from lower concentrated solution to higher concentrated solution means due to the driving force for osmosis is, that is by the osmotic pressure. You can see the diagram, students, here. This is a low concentrated solution. This is high concentrated solution separated by a permeable membrane. So that membrane, semi-permeable membrane, partially permeable membrane, it will allow only solvent molecules. It will allow only solvent, not a solute. Not a solute. Okay. So the flow of solvent that occurs from dilute solution to concentrated solution. Dilute solution to concentrated solution. You can see the net movement of water molecules from lower concentration to higher concentrated solution. So when the two solutions of unequal concentration are separated by a semi-permeable membrane, which does not permit the passage of dissolved solute particles, Okay. But flow of solvent takes place from dilute solution to concentrated solution. So this process is known as osmosis. This process is known as osmosis. So in this process, only solvent can flow, but not the solute, So which produces a pressure, okay, when the flow of solvent takes place, when the flow of solvent is from lower concentration to higher concentration. So where a pressure is produced, that is known as osmotic pressure, okay, which produces a pressure called osmotic pressure on the side of the more concentrated solution. You can see one more diagram also I have given, okay. Dilute solution, concentrated solution. The flow of solvent takes place from dilute solution to concentrated solution. Next one. Now we are going to discuss the process is reverse osmosis. Reverse osmosis process. So osmosis means we know that the flow of solvent is from lower concentration to higher concentrated solution through semi-permeable membrane. But here we are following the method is, okay, reverse osmosis. Okay, to the osmosis process we are following in a reverse way, in opposite way. Okay, nothing but very simple. Here the flow of solvent takes place from higher concentrated solution to lower concentrated solution through a semi-permeable membrane. But how? By applying pressure. By applying pressure on the concentrated side solution. On the concentrated side solution, high concentrated side solution, we are going to apply the pressure. We are going to apply the pressure so that the flow of solvent, the flow of water molecules that goes from higher concentrated solution to lower concentrated solution through a semi-permeable membrane. Okay. So if a hydrostatic pressure is in excess of osmotic pressure, so we are applying extra pressure here on the concentrated side so that the flow of solvent that will be reversed here. Okay. So that is forced to move from concentrated solution to dilute solution, okay, dilute solution through semi-permeable membrane. Okay, so this process is called reverse osmosis. So we are applying this to get a pure water. We are applying this method to get a pure water, okay, from sea water. Okay, so the reverse osmosis, from reverse osmosis, pure water is separated from contaminated water. Pure water is separated from a contaminated water. In ion exchange process also, what we have done, so by using cation exchange resins and anion exchange resins, we separated all the we have removed all the cations and anions present in water. Here what we are doing, we are taking a semi-permeable membrane. We are using a semi-permeable membrane. So that semi-permeable membrane, it allow only solvent. It allow only water. It does not allow any solute particles which are there in water. Okay. So when dissolved salts are present in water, that water is called what? Contaminated water. That water is more concentrated water, contaminated water. From that contaminated water, students, we are going to get the pure water. We are going to get the pure water. How we are following the process? We are following the reverse to the osmosis process. Reverse to the osmosis process. How it will be reversed to the osmosis process? How the flow of solvent, it takes place from higher concentration solution to lower concentrated solution is where when we are applying extra pressure, when we are applying pressure on the concentrated side solution so that we can flow the water, we can allow the water, okay, through semi-permeable membrane from higher concentration to lower concentrated solution. So this membrane filtration, it is called this membrane filtration, it is also called superfiltration. It is also called superfiltration or hyperfiltration. This is also called superfiltration or hyperfiltration. Now, so this method is mainly, it will be applicable, this method is applicable mainly for the desalination of seawater. Very good method, you know. So we can go for, we can take the seawater and we can go for reverse osmosis method. We can remove the, we can collect the, water we can collect, okay, by following this reverse osmosis method. That water we can use for domestic purpose and industrial purpose. Now, the reverse osmosis cell, students, you see, the reverse osmosis cell, it consists of a chamber. It consists of a chamber. See, you have to draw this diagram in the exam. It consists of a chamber, you see. Okay. So the reverse osmosis process, in this reverse osmosis process, the reverse osmosis cell consists of a chamber fitted with a semi-permeable membrane. Fit, you can see here, we are fitting a semi-permeable membrane. Okay, na? We are fitting in a chamber. We are fitting in a chamber semi-permeable membrane. Semi-permeable membrane, above which, above the semi-permeable membrane, we are taking what? Sea water. Fill the sea water. Okay. Sea water, or it is called impure water, that is taken, and we have to apply the pressure 15 to 40 kg per centimeter square pressure applied. We are applying on the sea water side. Okay, for separating the water, that is pure solvent, from the contaminants. You see, salt water we have taken, and we are applying the pressure. The flow of solvent that takes place from here higher concentrated solution to lower concentrated solution, so that you can collect the fresh water, so we can use it. So the pure water that is forced through this, okay, here we'll take salt water that is forced through the semi-permeable membrane. That semi-permeable membrane is made up of cellulose acetate we can take, and polymers we can take, polyamides, polymethyl we can use as a semi-permeable membranes. So the semi-permeable membrane which we are selecting, okay, that does not permit the dissolved solute particles, that does not permit the passage of dissolved solute particles. Okay, na? So this process is very easy. We can get the pure water. It is used to make pure water. It removes the ionic and non-ionic substances in the water. It removes the ionic and non-ionic substances in the water. It can also remove the suspended and colloidal particles present in water. Nothing but what, that semi-permeable membrane allows only solvent, no dissolved particles present in water. It does not allow any solute particles. You can remember this. Okay. So here, this semi-permeable membrane which we are using, so that we can use up to 2 years. Up to 2 years, you can go for purification of the water. Okay, na? So the life of a membrane is nearly 2 years, and it after 2 years, remove that semi-permeable membrane, and you can replace with a fresh one. Okay, so and you can go for again the process reverse osmosis. So by this process, sea water is made to fit for drinking. Means we can get the water by this method, pure water, that we can drink also. Okay, we can use as a drinking water, and the water which is obtained by this reverse osmosis process, that we can use in boilers also. We can use in boilers also for steam production. See, you can see in this diagram, students, you can see in this diagram. So this is the osmosis process. The flow of solvent from lower concentrated solution to higher concentrated solution. But in reverse osmosis, we are going in opposite way. Okay, means we are applying the pressure here. When we apply the pressure on the concentrated side solution, on the sea water side, the flow of solvent, the flow of water molecule solvent, it goes from higher concentrated solution to lower concentrated solution. Okay, so this is the reverse osmosis process. Okay, and here I will tell first advantages. Students understood what is reverse osmosis? Students understood? Students? Hello? Are you there?
Yes, ma'am.
Tell me what is reverse osmosis. In one line, you have to tell me what is reverse osmosis. What is reverse osmosis? What is solvent? Tell me here.
Water. Pure water.
Sea water, solvent is?
Pure water.
Water. Solvent is water. Solute is?
salt, and impurity.
Impurities. Solute is impurities and water is solvent. Now tell me what is reverse osmosis? What is reverse osmosis?
Flow
Tell
of
me.
solvent from low
Mama?
concentration.
Flow of
Solvent
flow of solvent
through a semi-permeable membrane.
From higher
Without-
concentration to lower concentration.
from higher concentrated solution to lower concentrated solution. Okay, you have to take a chamber and separate with a semi-permeable membrane, and you will take in upper part of the semi-permeable membrane seawater, and lower part you can take the pure water, so that the flow of solvent it goes from higher concentrated solution to lower concentrated solution. How it is possible, ma? How the flow of solvent that takes place from higher concentrated solution to lower concentrated solution? You have to apply the students.
Pressure.
You have to apply the pressure. Where you have to apply the pressure, ma? Students, where you have to apply the pressure?
You have to apply pressure on the solvent, which is greater than osmotic pressure.
You have to apply the pressure greater than osmotic pressure. Okay, from which side you have to apply the pressure?
Higher concentration.
Higher concentrated side solution on the seawater side, where you are taking seawater in the chamber. So from that side you have to apply the more pressure, so that the flow of solvent that easily flows from higher concentrated solution to lower concentrated solution through the semi-permeable membrane. Now tell me what is reverse osmosis? Students, what is reverse osmosis? What is reverse osmosis? Tell me. The flow of solvent from students.
Flow of solvent from higher concentrated
Concentration to low.
concentrated solution through a semi-permeable membrane.
That does not allow solute particles.
Okay. The flow of solvent from higher concentrated solution to lower concentrated solution through a semi-permeable membrane by applying
Pressure.
pressure. By applying a pressure. By applying extra pressure. By applying extra pressure, we can flow the solvent. We can flow the solvent from higher concentrated solution to lower concentrated solution through a semi-permeable membrane. Now, advantages. From this process, we can remove the ionic and non-ionic dissolved salts which are there in water, which are present in water. And it is very effective method. We can remove the colloidal impurities also present in water. That is silica oxide, for example. We can remove the colloidal impurities present in water. And the process is economical and convenient process. This process is economical and it is convenient process. And this process we can carry, it is carried at room temperature. This process can be carried out at room temperature. Okay. And it is suitable for converting seawater into drinking water. Okay, we can get a drinking water here. We can convert seawater into drinking water. And this water can be used in high pressure boilers.
Hi, friends.
Students? Now students. Hello.
Yes, ma'am.
Tell me advantages. Advantages, tell me, by this method, reverse osmosis method, what are the advantages?
It removes ionic and non-ionic salts.
Whatever the ionic, non-ionic salts we can remove. Next.
It is carried in room temperature.
Carried at room temperature. Then
Economical and convenient.
economical and convenient. Okay, so it is not expensive method like ion exchange process. Okay, this process is economical, like a low cost only we can get, means we have to buy only here what we have to buy semi-permeable membrane we have to arrange, and we can do the process very easily. Yes or no, students?
Yes, ma'am.
This process is economical, and rural areas where near the sea water, means near the oceans where the villages are there, that people they can easily get drinking water by this reverse osmosis process. We can get establish a plant there, okay, and we can get a drinking water. Yes or no, students?
Yes, ma'am.
Yes, ma. This process is economical and also
Convenient.
convenient. This process is very convenient. We can do very easily. Okay. And next, ma, it can remove colloidal impurities also we can remove, ma. And this water, the water we can drink, ma. This pure water which we are getting, that water we can drink. And this water is used where, ma?
High
This
pressure
water we can use in
High pressure
high
boiler.
pressure boilers. I will give you some applications, ma. See here. Wastewater also you can go for treatment method. Okay, na? Students,
Okay, ma'am.
wastewater also you can go for RO method, reverse osmosis process, treatment of wastewater, and desalination. What is desalination, ma?
Removal of salts.
Removal of salt present in water like NaCl. Okay, we are taking desalination process, removing salinity. Salinity is nothing but sodium chloride in water. More percentage of sodium chloride in water. In which water more percentage of sodium chloride will be?
Salt water,
Sea water. Okay, ma. So we go for desalination process, and we can purify the water. Okay, we are doing purify the water. So that water we are using in hospitals, ma. For dialysis in hospitals we are using, and for certain cosmetics we are preparing, and drugs we are preparing, means we are using in pharmaceutical industries this pure water which we are getting from reverse osmosis process. And also for injection, water for injection. So when we are preparing injections also we are using the water, this water. So very good applications are there for a reverse osmosis process, ma. So this water, finally we can tell this water we can use for domestic purpose and industrial purpose. Domestic purpose and industrial purpose we can use this water. So we completed second module, students. Understood, ma?
Yes, ma'am.
Yes, ma'am.
Yes,
Now,
ma'am.
I will tell you now how the questions you have to prepare in the second module. I will tell you so that I can start the third module. Everybody listen, ma. In this unit, water unit, 3 questions are there. 3 questions you can write in notes. 3 questions. One is EDTA method, ion exchange process, potable water. These are lengthy questions. Following me, students?
Yes,
Yes, ma'am.
EDTA method, okay, na? Ion exchange process, potable water. These are lengthy questions. Okay, short questions will be here. Types of hardness, temporary hardness, permanent hardness. Okay, next units of hardness. Clear, students? Units of hardness. Then reverse osmosis. How many are there?
3.
Short answer is types of hardness, units of hardness, then reverse osmosis. Clear, students? Then one more question. Disadvantages of hard water. First class we discussed, no?
Boilers get corroded.
Disadvantages of hard water for domestic purpose, industrial purpose. We have taken some
Later
examples.
won't produce, ma'am.
Huh?
Later won't be produced.
What, ma?
Oh, wait.
There will be formation of layers in buckets and all other equipment.
We discussed some industries like sugar industry, textile industry, boilers. That question is there. We discussed that topic, no? First topic, ma, disadvantages of hard water. You can see in your notes. Okay, na?
Pharmaceutical companies require pure water.
Yes, ma. So that 4 questions is short answers. First is disadvantages of hard water for domestic and industrial purpose. Then types of hardness. units of hardness, reverse osmosis. That 4 are short answers. Short answers. And 3 are lengthy questions. EDTA method, ion exchange process, potable water. These 3 are lengthy questions. Okay. So next, 2 types of problems. One is hardness problem, one is EDTA problem. So this is second module. Clear everybody? Clear everybody?
Yes, ma'am.
Yes, ma'am.
Okay. So what are the
Yes,
lengthy
ma'am.
questions? What are the lengthy questions you have to prepare in this module?
EDTA
ETA,
method,
EDTA,
ion
Potable
exchange
water.
process,
potable
portable
water,
process.
ion exchange process.
ion exchange. Short answer questions 4 are there. Tell me.
Types of hardness, units of hardness,
Units,
Disadvantages of hardness.
disadvantages of hard,
Reverse
disadvantages
osmosis.
of hard water.
Reverse osmosis.
Reverse osmosis. Problems, 7 are there problems.
Yes, ma'am.
Hardness problems and EDTA method problems. Okay, na? So this is the second module. We completed second module. Then we are going to start our third module. Okay, na?
Okay, ma'am.
Students, after completing third module, students,
Yes, ma'am.
after completing third module, we will discuss question bank. Okay, na?
Okay, ma'am.
Okay, ma'am.
Okay. Okay, students. Now, all of you write down in a fresh page in your notes, module 3. Write down module 3, engineering materials. Module 3, engineering materials. Students, you wrote? Hello?
Yes, ma'am, writing.
Write down module 3, engineering materials. Students, what is module 1? Module 1.
Electrochemistry and corrosion.
Electrochemistry and corrosion, ma'am.
Okay, second module.
Water technology.
Water
Water
technology.
technology.
Water
Third
technology.
module. Third module.
Engineering
Engineering
materials.
materials.
Engineering materials. Engineering materials. Now write down, students, what we are going to discuss in engineering materials is, so don't write this one. Okay, this one don't write. What we are going to discuss in engineering materials is polymers, rubbers and lubricants. Polymers, rubbers. So I am writing elastomers also. Okay, polymers, elastomers, that is rubbers and
You should
lubricants.
write that, ma'am.
You write. What we are going to discuss here in engineering materials is module 3, polymers, rubbers, lubricants. Now mid-one exam, we are going to discuss only polymers and rubbers and lubricants after mid. So in this module, we are going to discuss about polymers, rubbers and lubricants. For mid-one exam, we are going to discuss about up to only polymers we will discuss. Okay, na? Now, you write, students, what we are going to discuss, you write, no problem. In your notes, everybody write down polymers. First polymers you write down. First topic, types of polymerization you write down. Types of polymerization. First topic. Types of polymerization. Okay, na? Types of polymerization. Second topic, difference between thermoplastic resins, thermosetting resins. Difference between thermoplastic resins and thermosetting resins. Difference between thermoplastic resins and thermosetting resins. Third topic, compounding of plastics. Compounding of plastics. Compounding of plastics. Compounding of plastics. Fourth topic, preparation, properties, and uses of preparation, properties, and uses of PVC, polyvinyl chloride, comma Teflon, comma nylon 66, and bakelite. Polyvinyl chloride, Teflon, nylon 66, and bakelite. And next topic, biodegradable polymers. Biodegradable polymers. So these topics we are going to discuss in polymers, okay, for mid one exam.
మ్యామ్ ఎలాస్టోమర్స్ కూడా ఉంది మ్యామ్.
లేదమ్మా,
లేదా మ్యామ్? ఓకే మ్యామ్.
ఎలాస్టోమర్స్ మిడ్ వన్ ఎగ్జామ్ లేదు, టెన్షన్ పడకండి, సరేనా?
ఓకే మ్యామ్. ఓకే మ్యామ్.
లేదు. ఓన్లీ polymers ఉంది. Elastomers and lubricants will discuss after mid.
ఓకే మ్యామ్.
Only now, what are the topics, types of polymerization, difference between thermoplastic, thermosetting resins, next compounding of plastics, preparation, properties, and uses of, we have taken 4 synthetic polymers here, PVC, Teflon, bakelite, nylon 66. Next, last one, biodegradable polymers. So these are the topics we are going to discuss in module 3. In polymers in module 3. Now, students, first we'll discuss introduction. Okay, na? After introduction, we'll start the first topic, types of polymerization. So introduction part, I'm going to discuss polymers classification with examples. Polymers means classification of polymers with the examples. See the students now. Now which century we are?
21st ma'am.
21st.
See here.
21st.
Yeah, see, look at here. Okay, the scientist in the 15th century itself, Christopher Columbus, the scientist, he noticed that the natives of South America, they were playing with the balls, bouncing balls. That balls made up of latex of a tree. Latex means, you all know, white liquid which we get from the rubber trees. We will collect that latex, then we go for coagulation process, we will get a natural rubber. Yes or no? Okay, ma. So they were playing with the they are making like a balls, ma, that with the white latex. They're making like a balls and they're playing. Okay. So that tree is also called weeping wood, which is used to call weeping wood, ma. Okay, but he have not given a name. This Christopher Columbus, he noticed that some means they are playing with ball, that is like a polymer, he noticed, but he didn't given a name like a natural rubber. Who have given name to that as a natural rubber means, so this natural rubber, which was named by Joseph Priestley. So scientist Joseph Priestley, he have given a name as rubber. Why he have given name rubber means, because it is erasing the pencil marks from the paper. Okay, it is erasing the pencil marks from the paper. So Joseph Priestley, he gave the name as a natural rubber. He have given a name is natural rubber. Means from the 15th century itself, the scientists they noticed that about the polymers. Okay, ma? Now, in 1909, the scientist Beckeland, name is Beckeland. What he have done? He prepared a polymer. Okay, how he prepared a polymer? By taking a chemicals. What are the chemicals? Means phenol and formaldehyde. So two chemicals he used, phenol and formaldehyde. He prepared a polymer that is called phenol formaldehyde resin and named it as a Beckelite. So students, we use this Beckelite phenol formaldehyde resin, this polymer we will use, and we'll make the switches. We are having in our home switchboard, no? Switches. Okay. So that is made by the Beckelite polymer. Understood, ma? So this Beckeland scientist, he only prepared, ma. Okay. That is Beckelite polymer. Beckeland prepared, gave the name Beckelite. Understood, ma? Okay. The scientist Beckeland in 1909, he prepared phenol formaldehyde resin, which is named as a Beckelite. So he has been called now the father of plastic industry. Who is the father of plastic industry? Means Beckeland. Now he has been called as a father of plastic industry. So we will use in our houses switchboard, switches and all, that is made by this resin only, this polymers only, phenol formaldehyde resin, which is called as a Beckelite. Given the name is Beckelite, the scientist name is Beckeland. Now students, polymers are very, very important components in our daily life. Now we cannot live without plastic. Okay, we are using day by day everywhere as a domestic purpose or industrial purpose. We are using polymers. Okay, so the polymers are highly useful in domestic and industrial and medical field also. Yes or no, students? Yes, ma? Okay, so we are using polymers, domestic purpose, industrial purpose, medical purpose. Okay, so the following are the reasons for extensive use of polymers. Why we are using polymers like this means because most of the polymers are non-toxic. Most of the polymers are non-toxic and safe to use, and they are lightweight. Yes or no, students? Okay. If you take iron bucket, plastic bucket, which you can use very convenient way or easy way, which you can use, ma? Plastic only, no? Plastic bucket only you can use in a convenient way because it is light in weight. Okay. So they have low density, small, light in weight. So transportation of polymers will be very easy. Okay. So they have very good strength, good flexibility, and they're resistant to chemicals. Okay. And these can function as a good thermal and electrical insulators. Polymers can function as good thermal and electrical insulators. They have very good thermal insulating properties and electrical insulating properties. Electrical properties. So polymers we are using because of this also. So these can be molded and fabricated easily. Yes or no? You can make into any shape. Students. Okay. So these can be molded and fabricated easily. So they possess aesthetic colors. So we give very good English colors, whatever it is, we give very aesthetic colors to the plastics. Okay. And we use that plastics. Students, when you go to shop, you will see the color and buy. Students?
No, ma'am.
How you will buy? You want to buy one plastic bottle. When you go to shop, you will see the color and buy. What you will see when you go to shop if you want to buy any plastic item? You will see quality or you will you like that color you will buy?
Quality, ma'am.
Quality.
Everybody? See, quality. You see there is one bottle is there, brown color bottle, brown color. But quality is medium quality or no quality. You will brown color it is there, but quality is there. What you will do? You will buy that brown color bottle.
Yes, ma'am.
Quality is good. You will buy, huh? Or you will see for color only. Color also you will see. You are not telling me correctly. See, when you
I
go
will
to
see
shop,
both, ma'am.
both you will see. Very good, Nikhil. You will see
First
both.
color.
Huh?
First color.
First color you will see, not quality.
Yeah, ma'am.
Then you will buy the bucket. You can use only up to 3 months. You will buy.
Ma'am, first I'll see quality, then color.
First of all, you will see quality, then color. If both are there, then only you will buy. Yes or no?
Yeah, ma'am.
Yes, ma.
Yes,
in
ma'am.
Not there
plastic,
another shop. Huh?
Enti, what, ma?
If
And
not
then
there another
together.
shop, ma'am.
You will go to another
Okay.
shop.
Together.
Or you have to give a order to manufacturers. Yes or no? You have to give the order to get a good color and quality. Yes or no, students? Okay,
Yes,
ma.
ma'am.
So in plastic, we get very good colors, ma. Okay, na? And we have to see the quality also. Okay, we will use polymers in home and vehicles also we are using, ma. It is used to repair organs in medical field we are using. It can be used in purification of water also. Okay, I told you that cation exchange resins and anion exchange resins, we are using the polymers. Yes or no?
Yes, ma'am.
Polymer resins with the functional groups. Okay, it can be used in purification of water, and these are also used for in furniture and fabrics. Okay, ma. You know, nylon 66 that we make a clothes and all. Yes or no, students?
Yes, ma'am.
Okay, polyester clothes. So Dacron. So all these, ma, many uses are there by using polymers, ma. Okay, in all areas of the field. Okay. So I gave some points, ma. Okay. Now it is a Greek word, ma, polymer. Greek word. So in Greek, poly means many, ma. Poly means many, and mers means units or parts. Poly means many. Mers means units or parts. Mers means units or parts. Okay, in Greek word, poly means many. Mers means units or parts. Okay, so polymers definition we can know the definition. So polymers can be defined as these are large molecules. Polymers are large molecules. Okay, how they are formed? The large molecules are formed by linkage of small molecules. Linkage of small molecules. So we are linking a small molecules together and we are getting the polymer. So polymers are large molecules formed by the linkage of small molecules. So small molecules are called monomers. The small molecules are called monomers. Okay. So example is polyethylene. Example is polyethylene. So thus the repeated unit of polymer is monomer. Okay. So what is the repeating unit in a polymer is monomer. Okay. So what is a polymer means? The polymer can be defined as a large molecules formed by linkage of small molecules called monomers. So one simple example is I have given here. By taking a number of ethylene molecules, N I wrote here. Before the monomer, we write N. N indicates many. Okay, ma? So we are taking N number of ethylene molecules and we are adding together that ethylene molecules and applying heat, pressure and catalyst. And we are going to obtain polyethylene. Polyethylene. So before ethylene monomer, we are writing polymer. Poly means many. Okay. So this is a polymer. Polyethylene is a polymer. So this polymer is obtained by adding a number of monomers, that is ethylene molecules. Okay. So this is one good example for the polymer. Okay. Preparation of the polymer. Okay. Students will discuss in next class. Okay, na?
Yes, ma'am.
Okay. Shall I end the class?
Yes, ma'am.
Yes, ma'am.
Okay.